So welcome to our talk about one night at a metro depot. I'm Silvia. I'm working at Metro as a product owner.
And I'm Tobias from InnoQ, and I'm also working at Metro as a developer.
So what we are talking about is what happens in a night in such a depot. First question, who knows what Metro is doing as a company? Okay, most of the people. So it's a large retail and wholesale company internationally. And the question is, why is something happening during night at such a location? And the reason is so-called food service distribution, which short-term FSD, which means we are delivering our customers, which are hotels, restaurants, and caterers, overnight so that they have all the stuff that they need for their daily business. Because if you want to visit a restaurant, you want to get some food there usually, so they need fresh food. So most of them ordering food from us, but also non-food articles like office material, napkins, and so on. And the question is now, where does these goods come from overnight? We have some specialized FSD depots, so that are huge locations from 4,000 to 10,000 square meters, where we just store the goods for these FSD customers. So then during night, we will try to get all the goods from such a location. But in some cases, we also want to save money and don't store every good in every location. So we have also some really huge central platforms, which are more than 50,000 square meters, but they are then rarely spread over a country. And from these platforms, we then deliver overnight to the other depots and from there to the customers. And additionally, because in a depot you cannot have that many articles, we also have our Metro stores, which are the biggest ones around 25,000 square meters. And we also pick some of the articles from such stores. But the problem with a usual store is that you have normal customers visiting there and buying their stuff as well, which is good on the one hand, but on the other hand, you cannot manage the stock in the same case as you can do it in a pure depot, where you really know how much articles are in and when have they moved from which location to another location. In a store, you present the articles also in a different way, not optimized for delivery business, but optimized for people who are walking around the store and want to buy their goods. So that is the problem, that from stores you cannot deliver efficiently, but still we are doing that in certain ways.
But it also has an effect on the software you're building, because the processes you can implement with a dedicated depot are different than the ones you can implement if you want to pick from a store. So also from the software side, this has a great effect.
And also combining then the goods from different locations into one, and that all overnight. And if you imagine, a hotel is not ordering just one article, but 20 to 25 articles, which is then like that amount of stuff, for example. So this is not like your typical Amazon order where you just order 1 or 2 books, which can easily be picked, but you need to get together really a large bunch of goods. And these goods, like fresh food and dairy products, have the problem that they also need special cooling conditions. So you cannot just grab all that stuff and then store it for several hours in a certain area, because your deep frozen stuff will then be no longer eatable. So that is also something that you need to consider in the software and to manage with your processes. And this does not only needs to be considered during storage, but also during transport. You have to manage that the temperature is not going over a certain level, and you have to track that over the whole time. And the last part of the delivery business is then we do that with our own fleet, because we have also pre-aligned time slots with our customers, so you cannot just skip the shift that with some parcel service, but you need really your own truck and go then there. And the last challenge that comes on top of that is we are not doing that only in Germany, but we are doing that internationally, so really around the world. Which also means the software needs to run not only during night, but really 24/7, because we're doing that every day. So what happens now during a night? So what is the process, the business process behind it? The first thing, an order will come in from something which will look like a typical web shop, of course optimized for food and also for B2B business. But in general, it looks like a web shop you have seen before. But then the order comes in and someone needs to check. For example, customers have comments, some articles may not be on stock and we need to call the customer and clarify if we can replace it with another similar article, or if we can deliver it later the day or another day. So a lot of checks happen in that place, and you also need to check from where can I get the goods overnight. The next part that is then happening, we need to plan the tours. This is also different in depending on, do you have customers ordering on a regular basis or do you have customers ordering on demand? Then you need to do your tour planning differently, because you don't want your truck driving from A to B and back to C, but you want to have that optimized, of course. Then the most work in the depot happens, which is the picking. That means someone gets a mobile device, and the mobile device, like that one, it's not an iPhone, it's something more robust. And it will tell then the picker where he needs to go and what he needs to pick and how many of these articles. And then he walks around the depot, and of course that also should again happen in an optimized way so that you are guided in the right direction. And for that, of course, you need to know where your articles in which quantity, and you need to track all of that stuff in your system. When that has happened, which is quite a lot during a night, so large depots can handle more than 400 orders in a night, which is really a huge amount of goods. And if they are then all picked, they are waiting in the out zone beside the stuff that is still in the deep frozen area, for example. And then invoices get printed, delivery notes get printed, and also, for example, goods needs to be consolidated from the different assortment areas. And last but not least, the loading and the delivery itself will happen, again supported by mobile devices. And additionally, we have this flow of external picking. So from a central platform, for example, the order management will decide these articles we don't have on stock in our depot, they will come from a central platform and need to be consolidated during the delivery preparation. So the question is now, if you want to build such a system, you cannot just take 10 developers and let them work for some month, because you want to really have a software that is reliably running and has a lot of features in it. It sounds simple at the beginning, but the longer you think about it, you will figure out how many features you really need to steer such a whole process.
Especially if you want to consider developing that all by yourself.
Yes.
So this is mostly custom software which has been developed. So yeah, you need quite some developers and organization to get that managed.
Yeah. And the idea, when this project was started, I think it's now 3 to 4 years ago, it was decided that the organization should be split up into different teams, so-called verticals, which are cut based on the business processes and the business capabilities. So each team should be responsible for a certain part of the business, and therefore be as independent as possible on a technical basis, but also on feature basis. So of course, you will have a lot of verticals or product teams that are responsible, and they are depending on each other, but they should be really independent and not just split on an organizational idea, but really on the business. So if you take the whole process that we just saw, a very naive split would be, we have some order management team, we have some tour planning, we have some picking, we have a delivery preparation, vertical, loading, and delivery. So really cut it into verticals. But then, if you think a little bit about it, you will ask perhaps yourself, okay, but what is about all the master data? Where's that coming from? So if we sell articles, we need article master data, we need customer master data. Who owns the data of an order? Is it something that evolves through all these verticals, or is it owned by the order management? Second question. The other one is, who knows of these verticals where the stock is right now? So that perhaps should be somewhere in the software. And last but not least, how do you configure your location? Because if you imagine, if you have worldwide several depots, they will not look all the same necessarily, because you have different countries with different needs and different sizes of cities, so you need to configure your depot as well. So to come to a little bit more realistic vertical cut, it's not completely the reality right now, but very close by. So you will have something like an order management, which is more steering the whole process, and then you have verticals which own a certain part of this process, but they don't necessarily talk to each other. And below that, which does not mean you have layers in your software, but something that offers you the whole management of receiving the goods in your depot, managing that, and knowing where the stock is really located, which also configures your depot in certain parts, maybe the depot management. And of course, you need a lot of other systems around. You need the master data, which partially can be owned by the shop, for example, like article and customers. And you have other systems like a merchandising system, also responsible for financial stuff. And you have a till, which will print the invoices for you, because if you want to build also a till, there is additional, much more effort. So therefore, we reuse an existing system.
So that is also a challenge. Like, in a way, this is not a solution which starts on the green field.
Yeah.
We somehow have to incorporate all the existing functionality, which is still like the core of a lot of what Metro is doing. So somehow we have to incorporate that. But if you think about the numbers, if you think about the technology and the number of people involved in this, we're currently talking about 100 microservices which are enabling the blue parts of this software, so the whole fulfillment part of this software. And we have another 100 microservices which are then about for the shop to be developed, and there are like 70 devs for the order fulfillment part and 40 devs for the user-facing shop verticals.
Yeah. And right now, the country is live in at least 7 countries, so we're not fully rolled out to all countries yet, because you can imagine that is also a not so easy task. And so right now, during every day, we have like 8,500 orders that we are fulfilling every day. Yeah. And now we will have a closer look on that part of the software that we are in the team of, so which is picking and packing, which is definitely the most interesting part of that process. Definitely. So we will have a closer look at how such a depot looks like. You have on top the area where the trucks come with all the goods that will go into the depot. So a truck of Coca-Cola arrives, for example, and will unload all their goods, and then someone needs to check them, and then someone needs to put them to the right assortment area, which are the orange boxes over there. Some of them are cooled, some of them are not cooled. And then you can put the articles there to a picking location, so something I can reach as a human when I'm picking. And you have the storage level above, where you can only get to the goods with a forklift. So that is the part which we call the inbound process, so managing goods coming into the depot. This happens without any customer order usually, because you have forecasts, you know what probably the customers will order. So that is a huge different topic which we are not tackling at all. But we are then responsible for, if a customer order comes in, to check if all of the goods we need are in a picking location. Otherwise, we will trigger the system that goods are brought from the top to the bottom, the replenishment, and then a picker will go through the depot. And if you want to test that later on, we have a little demo application with us, so you can test that by yourself later, not in a real depot, but with some fake articles. And then you will walk around the depot, pick all the goods, and place them in a so-called buffer zone, which still has the same cooling conditions as the storage area. And then when the truck will arrive, all this stuff needs to be brought together, consolidated, and then wait in the right out zone where the truck will leave. So in a huge depot, you have something like up to 20 gates, and you need to manage that as well, because a human will somehow get lost. You can do that with pen and paper, but you probably want to have software for that. So there are 2 views mostly for our software. One is for the supervisor sitting at a desktop and checking if everything is going fine in the depot. So he will check, okay, I have different trucks leaving at a certain are planned to leave at a certain time at the depot, and I need to manage that all the stuff for these trucks are picked in time. So he will at a certain point decide, okay, I want now to start picking for this truck, and he can manage and see how much is already picked. And if he did that, someone will walk through the depot. And we have, so that you can get an idea of that, we have a video for that. And we'll guide you through how it looks like if someone goes through the depot. So first of all, you need to print labels, because we never trust the pickers, so we want to manage and to know in which of the boxes each article has been put. So you will first get some boxes and a pallet, and then you put these nicely printed labels on the boxes. Usually they are not that fast, so you really see there is a lot of work going on. So we now have our boxes, and now we take our mobile device, and it will tell us where to go in the huge depot. So now I'm there, and now I need to double check if I really have the right article. Of course we have. And then we say we put it into that box, we do it with the next article, and then we go to the next location. And now the job is completed, and all of our goods are in the boxes, and we will bring that to a so-called buffer zone. And then this was a very fast picker, and he approves that he really put it there. So thanks for my colleague who played that. So so the guy at the desktop will see, okay, he did his job well, and this is how the screens of the mobile application look like. So everything is displayed where you need to go, what you need to pick, and we will double check nearly every action by scanning barcodes of locations and articles.
So when you develop now services or product from Metro within one vertical, it's important to know in which environment, with which constraints we are working on. So on one level, like the system is constrained by some microarchitecture principles. So in general, like this concept of a vertical is one which is very important. It's just not just that the business or the verticals is separated by those verticals, but also a lot of work is put into that on a technical level. Those verticals can also exist in an independent way. So the verticals should be as loosely coupled as possible in process and data. Also, like the infrastructure which is used by those verticals is mostly independent. So we don't share any databases between verticals. We don't share any queues between verticals. All the communication between verticals runs over HTTP. So that is also some things we have learned from the past. And now we're even thinking about splitting the Kubernetes clusters which are running the microservices to split things on that level. Because also we saw that when we have some problem in one part of the system, it can also be useful like to have some boundaries on the Kubernetes level to make the single verticals independent of each other, at least from the parts which are really having different user bases as the shop and the fulfillment part of the system. Also, no code is allowed to be shared between the verticals. I'm talking about business code mostly here. And the verticals are deployed in a continuous fashion. So I already said that all the services are running in Kubernetes. We have a multi-DC environment, so also the applications are expected to run across multiple data centers. And the application teams, the vertical teams, hand over Docker images to the deployment pipeline, which then gets deployed to Kubernetes. For most of the time, the process or the verticals had only one persistence option, and that is Cassandra, for some historical reasons, but Cassandra is still the most prominent database on which most of this is based on. More recently, we also have, there's also support for Postgres, and Kafka can be used as well for messaging as well as persistent append-only store. And there's also some functionality like to ship logs and metrics and make them available for analysis in a central way. So how does this now connect to microservices? So within one vertical, we have to somehow adhere to the microarchitecture principles, but each vertical for itself has a lot of freedom how to develop a solution, because the solutions are very different, so the tools are very different, the processes are very different, so there's no rule on in which languages those single verticals are developed. So we have a handful of languages which are used, we have even more frameworks which are used to build the single application. That's more or less free to the vertical to decide how they organize themselves and how which technologies they use. So one big challenge we had when developing that system is interacting with other verticals. Because as we've seen from the business process, we are dependent on a lot of things. So we want to get notified about incoming orders because we have to know which things have to be picked. We also have to know where to pick those goods in the depot. So we have that dependency to the depot management vertical, and we have to know which orders belong to which trucks to know where to put stuff in the end. In our 1.0 version, more or less, of the software, things were pretty static. So we did know at some point how the situation looks like, and so we started off with an integration model, which basically allowed all our microservices to get the information they need from the external verticals. But at some point, this resulted in a lot of effort because we had a lot of duplicated integrations, and every time like those external verticals wanted to change something, it spread across the vertical. And also the integrations become harder and harder because after some times the things weren't so static anymore. So we had to know continuously when orders are changing, when trucks are changing, and when the locations are updated, things like that. We had to know that in a continuous way. So the integrations to other verticals grew more complicated, and having that in every single vertical was a mess. So we decided that we want to change to a different model. And you have to be aware that it is only allowed to communicate on an HTTP level between verticals because we want to reduce this couple. We don't want to have a central update of a central messaging queue or things like that, because those things cost you a lot, as we will talk about a bit later. So what we decided is to somehow centralize this integration functionality with what we call, or what is called, an ingest integration model. So we have a central ingest service which basically uses every mean possible or every mean available to obtain the data from other verticals. So that could be like simple pulling of a resource. At some points it's like consuming a feed which is available, but that more or less depends on what the dependent vertical is offering us. So we do the integration with whatever is there in the ingest service, and then publish those results within our vertical. And how does this publishing looks like? We basically transform the information we gather from the external verticals, reduce it and transform it to a set of information which we need, because, for example, we consume orders, but we are only interested in like 10% of the order information. So that's the part we extract there, and that is the part we then publish within the vertical with our Kafka cluster, which is available for our product. So now every service within Pick and Pack can now pick and choose whatever events they want to have. So they choose, for example, to use some order updated event. So they consume it, and what they do with it is they duplicate it again by writing it in their dedicated database. So they write it in their database tables, and only extract the information out of it which they need, and they only store it in the way which is nice for serving the requests of the user or some automated process. So that is very nice because it has a lot of advantages. So on one side, it's good for availability. We can basically live there, with other verticals being down for some time because we already duplicated a lot of data. It's good for performance because all user requests don't depend on other verticals, they don't depend on other services, they can mostly serve the user requests by just looking at their own database. So that is also very nice in terms of performance and latency. So within the vertical, we have like 3 services which are kind of obvious along the process. So we have one part which is about the wave planning. That's the nice screen you saw before, where the operator basically sits in front and says, yeah, I want to give this work now into the depot. And then it will do its work, like reserving zones, planning how big a job for a single user might be, in future also combining different works based on the ways the picker has to go. So that is everything which is done with wave planning. Then the picking process basically hosts this process you see on the mobile device, and afterwards the results are put into boxes or containers or trolleys, depending on the country, and then the packing process starts, which basically is then consolidating the things and preparing it for loading. And then we have 2 UIs, one for the supervisor, which is optimized like for desktop consumption, and one for the worker UI, which is only basically optimized for this, because besides of testing use cases, there's no need to test that on a desktop. And then we have some support services which are there for printing labels. So that's basically a programmable interface to print labels within the process, and also to reserve and manage zones and monitor the whole outbound process. So all those services are basically also part of the business process. So as the verticals are part of the business, the single services are also business oriented. So in DDD terms, they are more or less a host of 1 to several aggregates. So the ingest service we already saw. So on the UI level, we also set some architectural constraints. So this UI is a single-page application. It's developed in React, but we basically decided that we want to use an architecture where parts of this single-page application are hosted by one service. So it's very clear that if you click on one tab there, it's clear that the data is mainly coming from one service. Also, to make this more available and make this more performant, to don't have aggregations in the front end that much. Because that was also a problem, also a thing we learned in the past. Especially with single-page applications, it's very easy to say, okay, you have some resource available, but that's hosted by another vertical. It's not so bad, because like it's all you need. It's all you're ever gonna need. But then this other vertical comes and says, oh, we want to also put that information into that resource because this other vertical is needing it. So suddenly, like this like few kilobyte call is like a 2 megabytes call, and every time just to get this list of tours, you have 2 megabytes you have to get into your UI. So that's not nice. And in the next step, they discovered that they want to change from one service to another. So this resource has to change from one service to another. But since it's in production, we have to hide it somewhere behind a feature toggle. So now you have to ask for that feature toggle in the front end, and depending on the feature toggle, load either that or that resource. And obviously, oops, this doesn't make much sense, and this is very slow for the user. And we learned from that, and now we won't allow for it anymore to call any other vertical from our front ends. Also, the mobile application is interesting, because we also developed that one using React. It's not an Android application, so this one is basically a Zebra industry mobile Android thing. So you can, it's resistant in some way. It can cope with some temperatures we have in the depot, but in the end, it's a normal Android operating system. So for us, it was a choice to either go with an Android native application or to build some mobile application. But like, given the skills we had in our development team, we said, for us, we don't see a need of having a native application. Also, for them, they don't know that this is Android. They don't download stuff from the App Store. They only see this one application, more or less. So the consistency aspects are also not a problem here. So we integrated all the hardware features of this device, like scanning with a small wrapper app, which we release like, I don't know, twice a year. So this is very stable, so we don't need any or much Android skills to keep that working.
And the important thing is really, because we release this mobile app only twice a year, more or less, all other feature updates you can regularly get just via the web application, because rolling out that application then to many stores in many countries again, and updating all devices is also a tough job, so we are very happy that we don't need to do that too often.
Definitely. So how do SPAs and verticals fit together? Because on one side, like SPA is single page app is one page, right? So everything a user sees should be one page. So that is like a simplistic model of thinking about it. But in the end, like if you have verticals, that comes with a lot of consequences if you do that. Because like the argument is usually, the user wants to have this SPA and we don't want to have page reloads when we link between parts of the system. And to some extent, like it is a valid argument, but the costs of maintaining that are also very high. The amount of synchronization you have to do between the teams is very high, and the likelihood of breaking things along this way is also very high. So just a few examples. So one thing is like for one and a half year, I think, or 1 year, we have problems now to find a time where we can update React. Because there is no common schedule between all those verticals to agree on the right time of upgrading it. And upgrading React is not just like changing a version number and everything works. It's a bit of an effort. So that is really a problem. So you're stuck in terms of technology. You have this front end monolith. And also, it's very easy to break things because like a new developer is coming in, he's doing some CSS, and suddenly the thing is broken. So having that boundaries, even if you use single page app, having links between the verticals, owning your own DOM is really something which we are now focusing on doing and separating things to make this easier to do. So in a summary, basically the whole vertical can be considered a self-contained system. So the UI of the vertical is not shared by other verticals. Different services are hosting the system, but they all have a basically a unified UI. The persistence is owned only by this vertical. So we have our dedicated Cassandra cluster. We have our dedicated Kafka cluster. No one else is using that part. We decouple ourselves from other vertical by the means of replicating data from them, and one team is owning this vertical, but of course others are allowed to change when they have small fixes or technical updates or whatever is needed by them. And also the structure within the vertical is based on business functionality. So we host DDD aggregates within our services.
So to come a little bit more to what we learned from that project, because I think for all of us it was really a huge project, and during I think 1.5 years now we are in the project, we learned a lot and we want to share some of the insights. And I think one of the most important parts is that if you want to do digitalization or digital transformation, you need to bring together the business and the IT knowledge, because you can build software, but if you don't understand the business processes, especially if they are a little bit more complex and not so used to your daily life, you need to bring that together and find solutions. Because if you ask the business, they want the full-blown solution always and best tomorrow. So this will never work. And then you need to find an MVP. And then you need to check what is technical feasible, what is really needed from the business. And also the business needs to learn what are really the pain points in your daily life and what is really brings the most value in terms of costs to you as a business, and also comparing it with the development costs. So what we are now doing is onboarding new colleagues with a lot of business knowledge so that they understand and can bring in their ideas to simplify processes and so on. So that is really for us very important. Also, if we now want to bring a lot of new features into production, we also started working together with the business to think about what can we do to avoid a big bang? Because if you remember, you have 400 orders you want to fulfill in a night, and you want to change your software and the processes the people are working with, that might have a certain business risk with you, because if you don't deliver a restaurant in the one night, they probably will never order again. So you really need to work together also on an operational basis.
Right. So one technique we use to achieve that and to have that alignment is doing event storming on various levels. So to being able to find out a good structure within the vertical, having an understanding about the business process and deriving a good architecture out of that business understanding for us was really an important thing to do. So using event storming was really a nice way of supporting us in that process.
Especially when we started to develop new features that we all get a common understanding and try to figure out where small shortcuts are possible and where not, and so on.
Yeah. So one question we definitely had at one point is like we looked at our Slack. In our Slack, certainly, I don't know if you see it on the side, certainly looked a bit like that. I didn't get it completely on one screen, but we had a lot of people in our Slack. So and it grew and grew, and like the things we had to do in this pick and pack vertical, they were so diverse that it was really hard to get that developed with only a few people. But on the other side, it's definitely hard to have a huge team working like with one process. So we had to thought about what can we do to still be one vertical, but not be together in one room at all the time, not have like Scrum plannings with 23 people. That I don't know if anyone has done that, but it's definitely no fun. So we want to get rid of that as soon as possible. So eventually we came to a model where we said we are still one vertical, because it's not from a business side, it doesn't make sense to split that across multiple products, because like from a business side it's like very one unit. So we said we are still one vertical, so we still have some common rules we adhere to in terms of process and architecture, but overall we are like 3 teams which have like independent dailies, independent planning session. And so this works very nice, especially if you keep the flexibility of changing people between the singular teams. So that for us was a good experience. So now we have 23 people separated across 3 teams, and that's a pretty nice thing. Now, still, we are 23 people, and we somehow have to manage this thing called architecture. And I know that there are like multiple approaches for that, and there are pros and cons, obviously, how to do that. So the approach we involve to is like this model. So we now have no architect in the team, but we have something which we call an architecture weekly. And this is basically an idea that everyone, when they think they have something important which has to be decided across the team, they can put it on an agenda and give it some priority estimation, 1 to 3. And once a week we talk 1 hour about those things, and every participant of the meeting, which is usually only a small part of the team, but like different people most of the time, they decide on how to approach this topic. And that's pretty nice, because like people take part in decisions they care about. They don't take part in decisions where they don't care about. So that is kind of a democratic model of managing the architecture. On the other side, we noticed also that this doesn't work when communicating with other verticals. So what we also said is that there is a role of a tech lead, which is basically the gateway for other verticals to talk to organize things if things have to be organized in a cross-vertical way. But this tech lead is not necessarily the one doing all the decisions. It's more like a gateway for the team or for other teams to talk to.
So the question is when to split up a vertical. We figured out that you should definitely not do it just because of organizational reasons, but really of business reasons. So we had a lot of experience. Originally, the whole customer order fulfillment was one vertical, and if you now see the process, you will realize that was definitely not a good idea, so you need to split it up definitely. But therefore, you should always review regularly your vertical cut, because otherwise you will get probably monolith, which you cannot split up later on. So you can change your vertical cut, and you should really do that, but review that regularly. But of course, if you have many verticals, you are not alone. So we have talked already about, we can do a lot of things independently of other teams, but certain parts need to be aligned. So definitely if you want to develop bigger features, you need to align with the other teams when to develop them. And you need to align on the microarchitecture level, which is also probably quite easy, especially if it will not change too often. But when it comes to support and operations, you need to align with all the teams to have a common understanding of processes, because if you want to solve a problem in production, you need to know how to reach the other teams and how to document then problems and how to share tickets between the different teams. So there are certain parts that you need to align over all teams. And the other thing that we learned, or what is one of our rules, if you build it, you run it. And yes, we really mean that by that. So our team is 24/7 responsible for having our software running. So that means every one of us is doing shifts, night shifts. So we have an emergency number and we are getting called. And at least what we came up with is a somehow 4 eyes principle. So nobody of us will never be on a shift alone. So we will always have 2 people. So you never have the feeling that you will be facing a problem alone. And also we do this 4-eye principle when we do development for code reviews and so on, to ensure a certain quality already upfront, but also if you then need to make decisions during night and something like that, you will never be alone. And the other thing is, if you follow this rule, you will develop your software definitely differently. Because if you develop it and you see, or you do a code review, you will ask yourself, will I understand that at 3 o'clock in the morning, and do I want to face that code then? And this really helps to ease some of the decisions you make, and also how you document and how you will log. Because really at 3 o'clock in the morning, you want to have it as obvious as possible and as easy to find and things like that, and just follow a recipe and not start solving hard problems.
Yeah, and you develop some routine of also like being able to deploy things, to redeploy things, to monitor where things are in the deployment workflow. So all those things, like basically everyone is doing it, because really when you do that at night, you basically have to be able to remember. You have to you have to do that. You have to have done that several times before, so that is also a good thing. Yeah, like becoming resilient is something I already talked about. So when having those multiple verticals, especially, it's you somehow have to shield yourself from effects happening in other verticals, and we had that for quite some time in the project, where this was not like a dominating factor, but it was also very interesting because we saw the effects when not doing that, when doing synchronous call in the microservice architecture, because you can do so. And someone said, like, Metro, it is not different than Netflix, so we do it like that. So you really have to be really have to be aware of those kinds of things. And like, I can't hear the Netflix comparisons anymore. So probably your enterprise is not Netflix.
Yeah, and you really don't want to tell someone, yes, because our service failed, because that service failed, because that failed because of another service was failing. So we really had that situations, and other people will look at you and, why are you doing that? And you say, yeah, sorry, it's like that. And what helps you in such situations is definitely monitoring, because if someone calls you and says, the system is not working, and you have a graph like this, you might believe him. And you probably know also where to start. Because at the beginning, we had a time where we didn't have monitoring. And yes, the people were calling us, we said, yeah, okay, we will try to figure out what is not working exactly. So with that graph, it is really a good thing. So you can easily identify where the parts are broken. But what is even better, if the system is telling you that something broken, so if you have alerting. Because at the beginning, really, the customer was calling us. We said, yeah, let's have a look. OK, now we know it. Now we are more or less in the situation to be able to call our users and say, we know there is something going on, be aware, we are already on it. So we really came from reacting into more or less preventing then situations and to be alerted right at the moment where this starts to come up over the red bar. So at that point, the users will not recognize it, so we can have still some time to react. But this always means you really need to know your system.
Yeah, you have to know that is another aspect of knowing the business, because also for support, especially given the complexity of the business we are running to, you really have to understand the business to even be able to do proper support. So if your problem is not just like the RAM is full or something like that, you really have to understand the business domain to be able to know the dependencies and to be able to really fix the problem in time. But you also have to know the software on a technical level. And that is also a challenge. Like if you have like 23 people, 15 of them developers doing support, and 2 of them being available on a night shift, you somehow have to make sure that at least those 2 people are able to do a good support job. So you somehow have to see how you spread knowledge across the team. So that is definitely a challenge. So like code reviews can, in our experience, can help with that. Pair programming can help with that, but also like the onboarding process is a really important part of that equation.
Even more important, every incident gives you the chance to learn from your mistakes. So that is really important for us. And I think every incident helped us then to improve for the future. And the probably most biggest challenge that we have still in the project is to ensure our quality, but still deploying every day.
Yeah. So, I mean, nowadays it's easy, like people say, continuous deployment, that's just what you do. But it's still a challenge if you have done mistakes in your architecture. So you have to somehow balance, are you confident enough to do deployments all the time? So still, because of existing dependencies in the software, we are now in a model where we continuously deploy to PP, but we still have 1 deployment run a day to prod. And fix that deployment run to all Selenium tests passing, and even in some cases also some manual tests passing. So for example, we also have to support, because it belongs to our vertical, basically the old picking application. And the old picking application is a Windows CE version. And I'm not sure if you have done front-end automation test with Windows CE. So we are not very experienced with that. So our decision was, for the time that this is still in place, we have to do this manual testing. And it's really not nice, but in some cases, it's really hard to find a proper automatization which works out for you. So somehow it's still a balance if you want to deploy all the time.
Yeah. So what we really learned all over is that you should prepare your systems and your organization for continuous improvement, because your system, especially in such a size, will never stay the same.
Yes.
So, that's it from our side, and we now have some minutes left for questions. So there's...
Questions?
Yes, I was quite surprised to hear that in the beginning of your talk, I guess, you were advocating for HTTP as a cross-vertical communication pattern and against messaging.
Yes.
I would do quite the opposite, so I'm quite interested in hearing the reasoning behind that.
Yeah, I mean, the question is, I mean, you can't generally say that HTTP is bad for that case and messaging is good for the case. Like we had another talk this morning that like vertical is like messaging is perfect for sagas and stuff like that. And it is true, like messaging has its advantages, but still, in the most ways you do messaging, you couple yourself from the programming interface to some product. And that's not like we want to change our database from A to B, it's not like that. But I give you an example where this has been a problem for us. So for example, for a long time, we started with Cassandra in this project. So one Cassandra cluster was shared across the project. And that's not bad because like it's nice because you can balance your load across the cluster and obviously no one was sharing tables. Each vertical had their own table space and everything was great. But then finding a right time to upgrade from Cassandra 2 to Cassandra 3 because everyone had to update their clients. And now, what was the keyword which was now...
entries.
Yes, entries was suddenly becoming a keyword for a SQL, like the query language of Cassandra. So everyone like had to figure out like to change that and things like that. And now get this organization going for 200 developers. It's really hard to do. It's like the React update in a way. You couple yourself because you have this central dependency on a technical level. And if you want to do upgrades at any time, you have this coupling on this level. So that is something like you have to reason about. Like, what do you want to have the perfect technical solution which makes things simple but couples us, or do we want to reduce coupling? And Metro decided to reduce coupling on that level, and I think it's a good decision.
Especially as the different products have different pressure on a feature level. So it will never be the perfect time for all teams to do it in a certain point in time. So therefore, this is really something which is perhaps project specific, that you don't have one solution which has one timeline or one roadmap, but you have different roadmaps going on in all these verticals at the same time. So that is...
But still, like having those messaging features available is still an open question. So currently we're talking about having like a Kafka as a product or Kafka as an infrastructure part with like dedicated HTTP 2.0 APIs, making it available, but with a stable API also across versions. So things like that we're currently discussing and not decided. So we cannot ignore this problem given for some features, but still the default for us, I guess, is the default for us is HTTP, and I would also advocate it for other projects.
Let's say two more. I'm here. Thanks for the talk. My question is, why did you decide to build this system by yourself, not buy it? Because it looks like warehouse management, supply chain.
So that decision was definitely made before we both entered the project. But what you need to know is that so there is already one software in place, which is also customized to Metro, and you have 26 countries with different legal things. And at one point, it was made the decision that if you want to optimize your business really in this FSD part, then probably a customized solution would be better. So if you look at standardized warehouse solutions, they will probably cover your features at a certain point. But for example, I recently saw a standard WMS solution, and then the mobile device was not looking like what we've showed you, but it was a telnet-based interface. So you can offer that today, but it's probably not what you really would say is a modern solution. So
the question
but the discussion is still going on about...
The question is really like, do you think that this part of your software gives you a competitive advantage? Yeah. And like all other players in the field, like Amazon also decided to build their own product, fulfillment solution because they decided for them it gives them a competitive advantage to be able to deliver things faster as other companies do. And that is just a decision. For some areas it's like key and they want to have a competitive advantage. For other areas they still use a lot of standard software, so it's not just everything is built by Metro, but for things they want to have a competitive advantage.
Yeah, exactly. There's another question.
One last question.
Yeah.
Yes, hello, thank you. My question is, you obviously came from monolithic legacy software, right? So how did you manage to build the vertices? Did you implement it in an abstraction layer, or did you just said, yeah, we're writing each vertex as shiny new on their own?
So there is still the old software in place, and it's still used for a certain part of configuration, for example, but mostly the whole MVP was developed, and at a certain point, one country decided, okay, that is good enough for us to switch completely to the new solution, but it was only started in one country, and now we are rolling it out to more and more countries because, of course, different countries, different legal restrictions and so on. So therefore, there was first a big development part needs to be done, and then we had it over. But still, like, for example, the old mobile picking solution, that was, for example, still in place, and we prepared an interface which is behaving like the old legacy system. So yes, at some points we took old parts still, and we have interfaces. We have, for example, importer jobs running between the old system and the new system.
Yeah. Also, there, like, the application is a big key. Yeah. So, like, you can have like a one service, non-scalable solution, like suddenly exposed to the web with all the things. So for those parts, we like duplicate this. So, like, data is duplicated. For some parts, there are caching solution, and those old systems are still like developed because they are still like a big. It's not that they stopped developing those systems. So it's in a way like a two-speed IT thing. So all products are still developed, but with other rules than the new products. Yeah.
Okay,
so,
thank you.
Thank you very much.
Yeah.
So if